Hi everyone. So we'll be starting our next topic, which is your standard hydrogen electrode. Okay, wait. The next topic name is standard hydrogen electrode. This is also called as SHE or standard hydrogen electrode. This is also called as your normal hydrogen electrode. Normal hydrogen electrode. So you can just name it as SHE, that is SHE or NHE, normal hydrogen electrode. Now, whenever we were studying the previous concepts, you must be knowing that we were taking an electrode along with its own solution, right? Do you remember in your electrolytic cell, we were taking zinc along with your ZnSO4, right? Zinc and its electrolyte, right? But here, you first thing which you need to remember is this is your gas ion electrode. This is your gas ion electrode. One side you will have a gas, the other side it will be having its ions. So what is the gas here? The gas here is H2 and your ion is your H plus. So it's a gas ion electrode. And what? It is a reference electrode. We consider this as reference electrode. But who told this to consider this as a reference electrode? Reference electrode, IUPAC told. IUPAC told us, please consider this as a reference electrode. So what do you mean by reference electrode? We'll understand it later. First, just understand that it can act as your anode half cell also. It can act as your anode half cell also and your cathode half cell also. Cathode half cell. Now you must be knowing that in anode mostly your oxidation takes place, right? And in cathode your reduction takes place. So just remember, reduction. So just remember, in anode obviously oxidation takes place and in cathode your reduction takes place. The next and the last point which you have to remember is its standard reduction potential as well as its standard oxidation potential. Both are equal to 0. Like they are assumed to be equal to 0. So E naught of H plus half H2. How this is half H2 and all we'll understand by reaction. Don't worry about it. We'll study it later. So E naught H plus and half H2 is equal to 0. This is your actually oxidation happening. And E naught of half H2 and H plus half H2. Sorry, this is your oxidation happening, this is your reduction, will be equal to 0. Now, how does this happen? Why there is an half H2 and H plus? We'll understand it by your reactions only. So, this is your standard hydrogen electrode, also called as normal hydrogen electrode. It acts as a reference electrode and it's both standard reduction potential and standard oxidation potential is equal to 0. Next thing which we need to study is its construction. How does the construction of standard hydrogen, because it's not a normal electrode, right? It's a gas ion electrode. So its construction will naturally be different. How will the construction be? You have a platinum electrode here. You have a platinum electrode with a platinum black foil. This is your platinum black foil, okay? So here you have a platinum electrode and here you have a platinum black foil. PT is platinum. Now this is basically covered by a glass chamber. Okay, glass jacket, you can tell. This is basically covered by a glass jacket which has a hole in it. Now from this particular opening your hydrogen gas is going to enter. Hydrogen gas is going to enter from this particular hole. Now they all are dipped in a solution of HCl or H2SO4. Let's assume it's HCl. And the molarity of H plus, so it has H plus ions and Cl minus ions, right? So what happens basically is your hydrogen gas enters from here hydrogen gas is entering and the platinum foil absorbs, the platinum foil will absorb or adsorb the hydrogen gas. So some of the hydrogen gas is absorbed in this platinum foil and the rest of it will just simply bubble out. So there will exist, so this is hydrogen gas getting absorbed and here you have H plus ions everywhere, right? So there will exist an equilibrium. What is equilibrium and all we'll study in the chemical equilibrium topic. There will exist an equilibrium between your H2 gas and your H plus ions. H2 gas and H plus ion. Where is the H2 gas? H2 gas is in the platinum foil. And where is the H plus ions? H plus ion is in the solution. This is how the construction, this is how your She electrode looks like. Okay. Now, I told you in the beginning that She can act as a cathode as well as anode half cell. Now, let's see how does it act as a anode and cathode half cell. So, do you remember how does an anode behaves like She as anode half cell? In anode, what things basically happens? In anode, basically your oxidation is happening, right? What do you mean by oxidation? Oxidation means loss of electrons. And what was the trick to remember? Lone. Left side oxidation, anode negative, right? So oxidation happens at anode. So what is oxidation? Loss of electrons. So now you have your H2 gas. What's going to happen? Oxidation means loss of electrons, right? So you will be getting 2H plus 2 electrons. Why I have written 2? So that to balance the charges and all. I can write it as this also, half H2, like just divide this full reaction by 2. Half H2 is giving me H plus electron. I can write it like this also, but this is much better way to represent. So H2 is giving me 2H plus 2 electrons. So here, as you know, your standard oxidation potential, that is your E naught, is giving you H2 and H plus will be equal to your 0, or most probably half H2 is giving you H plus will be equal to 0. And there is a different way of representation of your She. And what is the representation? Platinum, just write it on the outer end. Whenever we are taking anode, platinum, write it on the outer end, because from platinum your H2 is coming. So write it like this. Platinum, H2 is your gas. In gas we usually take pressure, right? So we'll write pressure P1 atm. Then H plus aqueous, just molarity 1 m or anything. So this is how you represent She as anode half cell. Platinum, because hydrogen is coming from platinum. This is just an exception, not an exception actually. This is how you represent the hydrogen wherever your hydrogen cell is coming. So PT first in your anode half cell, then H2, then H plus. PT, H2, H plus. This is how you represent She as anode half cell. Now, can you please try it for cathode half cell? Just pause this video and try for cathode half cell. It will just be opposite of what we are writing here. How will we write now cathode half cell? I'll just write it here only so that it becomes more easy for you to distinguish. Second we are writing is She as cathode half cell. What happens in cathode? Cathode reduction happens. What is reduction? Reduction means gain of electrons, right? Just write this particular thing in the opposite fashion. So 2H plus 2 electrons is giving you H2. Or you can write it as H plus electron is giving you half H2. Like just dividing the full equation by 2. This full equation by 2. Okay, and how will you represent it? That E naught of, what is coming first? H plus, right? So H plus half H2 is equal to your 0. And how will you particularly represent it? Just reverse it. You know, either you learn anode half cell or cathode half cell. Better learn anode half cell, cathode half cell, just opposite you have to do. So cathode half cell you need to write it as H plus, H2 and PT. Just the opposite, just the opposite. So this is how you represent it as anode half cell, and this is how you represent it as cathode half cell. Okay. Okay, now we'll do a question. Okay, 1 minute. Now let's see how do we determine the standard hydrogen electrode as a reference electrode. So we'll just see use of your standard hydrogen electrode as your reference electrodes. How do we, why it is called as a reference electrode, we'll study here. Use of She as your reference electrode. Do you remember, like, we were doing this electrode potential topic and I told you zinc will have some value, Zn2 plus will have some value, right? The electrode potential values and all. So how do we actually determine it? Like, you know, it's practically impossible. It's impossible to find the absolute potential of single electrode. It's impossible to find the absolute potential of single electrode. The absolute potential of single electrode. So what will we do? We'll find with as a relative electrode potential. We find the relative electrode potential with reference to She. Why? Because She is standard oxidation potential as well as standard reduction potential is 0. What does this mean? Like, if I suppose I give you an electrode, I'm telling you please find the standard reduction potential of this particular electrode which is made up of zinc. So what you did, you are just dipping the zinc electrode in ZnSO4. Now what to do? You don't know how to find the standard oxidation potential or standard reduction potential, right? We cannot find the absolute value of it. So what will we do? We'll find it as a reference. How reference? Just connect this, like if you are taking this on the left hand side. So just what we'll do? We'll take your hydrogen electrode, your standard hydrogen electrode on the right hand side here. Like you know the apparatus already, platinum wire, platinum foil, there is a glass jacket here and here, and you connect with it. Let the electrons flow. And then, because since here the standard reduction potential, oxidation potential, everything is 0. So whatever value you get in ammeter will be its standard oxidation or standard reduction potential. Okay, we'll do it by a proper example now. I have given you, suppose, a zinc rod. Zinc is acting as anode here, suppose. Okay, like you are just taking, because anything you can take, right? You can find standard reduction potential or standard oxidation potential and just reverse the sign. You'll get the opposite. So this is my zinc which is dipped in ZnSO4 solution, and this is acting as anode. Why anode? Left side always anode, lone. Now I need to find the standard electrode potential of this. So what I'll do, I'll just connect it with my hydrogen electrode. So this is how your hydrogen electrode used to look like platinum wire here, then you had a glass jacket around it, it was dipped in HCl and all, right? This is my platinum electrode. Now I know on the left hand side my oxidation is going to happen. So zinc will give me Zn2 plus 2 electrons. And here, since my reduction is happening, what is reduction? Gain of electrons, right? So here what is happening? 2H plus 2 electrons is giving me H2. You understood these both equations, right? So now let us assume that the voltmeter told me that voltmeter reading is X volt. So this X value will be your E naught. E naught of cell will be E naught. What is E naught of cell? E cathode minus E anode, right? So E naught of E naught will be X. The ammeter showed a reading X. So now we got to know that E naught value is X. Now what was the E naught formula? E naught cell formula, if you remember, it was E naught of cathode minus E naught of anode. Which is cathode? Cathode is this. So cathode is 0 minus X. So what is E naught? Sorry. So E naught value you know is your X. What is your E naught cathode here? E naught cathode is 0, right? Because standard oxidation potential as well as standard reduction potential is 0 for everything. So 0 minus E naught A is equal to your X. So what is the E naught value of A? E naught of zinc is your minus X. Then minus X is equals to your E naught A. This is how we find the electrode potential of all the electrodes from standard hydrogen electrode. Now we'll do just 2 questions and wrap up this video. So your first question is, find the electrode potential. What you need to do? You need to find the electrode potential at 25 degrees Celsius for. You need to find the E naught, right? Sorry, E of this particular reaction. H2SO4 aqueous 0.05 m and your PT in H2 in 1 atm. So you need to find the electrode potential of this. Now you know something is happening with H2SO4, right? You need to, since H2SO4 is written here, it means H2SO4 is undergoing oxidation to give you H2. So H2SO4, what is the molarity given? 0.05 m. It is breaking down into 2H plus here, right? 2H plus. So what does it mean? You need to like just go through your mole concepts again for this clarity. H2SO4 is breaking down into 2H plus. Why? Because there are 2 hydrogens. 2H plus. 2 will come here. So 2H plus. So it means what will be its molarity? 2 into 0.05, which is equal to your 0.10 moles. Okay. Now in the other end, therefore like your H plus, what is happening to your H plus? What are you getting? H plus in aqueous form and PT in hydrogen form. Now H plus, total H plus, what did you get here? 0.1 m and here it's 1 atm. Simply apply the formula, Nernst equation. E cell is equals to your E naught cell minus of 0.059 by m n log base 10 product by reactant. Product by reactant. What was your N? N will be 2H plus plus 2 electrons, right? N will be 2. E naught of cell will be 0, right? Because it's standard hydrogen electrode here. So E naught of cell will be equal to your 0 minus of 0.059 by 2 log base 10. Log base 10. Now what is the product here? H2, right? So what is the concentration, like pressure of H2? 1 divided by the reactant. Reactant is 2H plus. So it will be 0.10. Can I write it as 10 raised to the power minus 1? Thus I can write it as 10 raised to the power minus 1, right? So 10 raised to the power minus 1 raised to the power 2, because this is 2 coefficient here. When you solve it, you will get the answer as minus 0.059. What is the unit? Volt. This one will be your answer. Understood? What we need to do here, like just a quick revision. You need to find the electrode potential at 25 degrees Celsius for this particular reaction. You know H2SO4 is breaking down. It's breaking down into 2H plus, right? Now H2SO4 broke down, like whenever your platinum is present on the outer end, you know something with reduction is taking place. something with reduction is taking place. But how many H plus ions? See, everything is same, but just instead of your H plus, like your hydrogen electrode is like this only, instead of HCl here we have added H2SO4. So if you have added H2SO4, there is equilibrium between H2 and 2 H plus ions. That's why this full thing we have done. H2SO4 is giving you 2H plus. 2H plus means how much molarity? 2 into 0.05, which is equal to your 0.10 m. Simply have this reaction which we already studied previously and apply the formula. E naught of cell will definitely be 0. Why? Because it's hydrogen. And then you find it out what will be the E of cell. E naught of cell, E naught, standard oxidation potential, standard reduction potential for any hydrogen electrode will always be equal to 0. Okay. So you understood, right? This is the logic. This is where your hint is that the reduction is happening. When the platinum is present just extremely right hand side, it means reduction is happening. When platinum is present extremely left hand side, that means your oxidation is happening. One more and last question will do. Try it on your own. The question is, find the electrode potential at 25 degrees Celsius for an electrode which is in contact with a solution whose pH is 10. So what you need to do? You need to find the electrode potential at 25 degrees Celsius for an electrode which is in contact with a solution whose pH is 10. Now if you know the equilibrium topic, you might be knowing pH equals to 10. What is pH formula? pH is equals to minus log of concentration of H plus. So what is the concentration of H plus here? Concentration of H plus will be, just do the antilog of 10, that will be 10 to the power minus 10. 10 to the power minus 10 m. Okay. And the equation which is given is PtH2H plus. If Pt is here, you exactly know that oxidation is happening. Just apply the equations. 2H plus plus 2 electrons here. Apply the Nernst equation. E of cell is equals to your E naught cell minus of 0.059 by n log base 10 of your product by reactant. What is the product here? H plus raised to the power 2, and here you have H2. H2 is definitely 1. This is equal to your 0. So minus of 0.059 by n. How much is n? N is your 2. Log base 10. How much is the H plus concentration? 10 to the power minus 10, 2. And your H2 is your 1. And when you solve this thing, 10 to the power minus 20 it will become, right? And this thing will jump here. So minus of 0.059 by 2 into 20 minus 20 will be equal to, like when you solve it, you will be getting minus of 0. Okay, this will be plus 20, right? Minus of 0.59 volt. This is how you do all the equation. The major tip to identify whether the oxidation is happening or reduction is happening is this platinum here. Okay, I hope everything is clear in this video. So from next video, we'll be covering electrochemical series. It's quite easy. I think we'll be able to cover a lot in a short video. Yes, thank you so much.